All right, using the graphs to following the questions, some more real life applications or word problems basically. We have, a few things asked of us here for this graph. And really, the question and the graph are equally important, so make sure you don't overlook one for the other. The question tells us a lot, the graph tells us probably even more, but again, I would not skip over reading the problem because there's some helpful information here. So a population of squirrels doubles every year, so it's doubling, so that's going to be a growth function, which obviously the graph shows me that as well. Initially, there were 5 squirrels. A biologist studying squirrels created a function to model their population growth. The graph of the function is shown here on the right. So you have part A, which is what is the growth factor? In other words, what is B? And remember that B is the rate of change. That's what it's growing by each time. So I notice here, if I just look at the major plotted dots here, I can make myself a little table. So X and Y, when X is 0, Y is 5. So that tells me, okay, before any time has passed, they were 5. In other words, it started with 5, which makes sense because my problem told me that. 1 is 10, 2 is 20, 3 is 40. So I have myself a little list of things. And again, remember when we're dealing with exponential functions and we're trying to find the rate of change, we don't really care about X, we only care about Y. So what is this changing by each time? Well, remember that if you're talking about exponentials, which this test is entirely over exponentials, you're talking about what can I multiply to move down the sequence of numbers. So 5 times what equals 10? 2. 10 times what equals 20? 2. 20 times 2 equals 40. So it looks like all of these are being multiplied by 2. Well, the good news is if you can do that, then you can tell me what B is. B is the factor in which they are increasing or decreasing. In this case, it is 2. So our factor, or B, equals 2. What is the initial value? Well, there's 2 ways to figure this out. They tell you that the initial value was 5, but if for whatever reason you didn't catch that, when you look at your table, if you make your table, or you could look at your graph where it starts, it's the initial value. So there's 3 different ways here that you can figure it out, and the initial value is going to be 5. So you start off with 5 squirrels when 0 time has passed. Part C, what is the reasonable domain? So reasonable is underlined there because you have to think about it in context. Yes, exponentials usually have all real numbers as their domain. But if I'm dealing with this particular situation, does it make sense to have negative squirrels? I'll go ahead and answer that for you. No. If there were negative squirrels, then we wouldn't even be conducting the study or counting the population growth. So we are going to have at least 5 because as 0 time has passed, you started with 5. So the domain can be 5, or I guess we could have less than 5. We could have 0 squirrels. So let's say not even 5 is the minimum. We'll say 0 squirrels is the minimum. So the reasonable domain would be from 0 to, well, there's no limit. Hopefully we don't have infinite like squirrels, but there's no limit to how they can grow. Is if they're growing, there's no way to stop it. Really, we can't just have a negative squirrel is all that means. So our domain could be anywhere from 0 to positive infinity for the X. Remember, domain is X. What is the range? So if our X's can be 0 to positive infinity, meaning, oh, actually this isn't the squirrels at all. This is the time. So the time that's passed. Well, you can't have a negative time. You can have no time, and you can have time from here and out. So that still makes sense as 0 to positive infinity. Now, range is based on our domain. So if we have 0 time, what is the least amount of squirrels we can have? Well, if X is our 0, or if X is our time, and 0 is the furthest we can go on the X-axis, well, which Y matches up with that point? Well, 5. So the minimum amount of squirrels we can have is 5. So that's where our range starts. In other words, our initial value. When X is 0, 5 is Y, or Y is 5. So that is the minimum amount you can have, assuming that we can't go into decimals or negative numbers. So if the range is 5 to start, what is the maximum range that we can have? Well, we know that as time goes, if this graph holds and it goes on forever, then as time goes infinitely in the positive direction, the population will also grow infinitely. So the range is a positive infinity. And finally, E, what is the average rate of change for the interval 1 to 3? Remember, this is your x1, this is your x2. Because they're in brackets and you're asked about average rate of change, these are your x1 and your x2, not a 0.13. So x1 and 3, I didn't have to make myself another table, but I'm going to do it anyways. So 1 and 3, when x is 1, y is 10. When x is 3, y is 40. And then all I need to do is find the change here, and I'm not multiplying here. When I'm finding average rate of change, I'm just finding y2 minus y1, so 40 minus 10, which is 30. And then x2 minus x1, which is 2. So again, y2 minus y1 divided by x2 minus x1. That's 40, which is y2, minus y1, which is 10. So that's 30 divided by 2. 30 divided by 2 is 15. So the average rate of change during that section is 15. Sorry, that got a little crooked there.